Okay, let's give you guys some more practice. So find this area here. Find this area here from 0 all the way to infinity. From 0 all the way to infinity. So press pause and have a go. Okay, so to do this, our normal routine has always been to integrate it from 0 to an arbitrary point, let's say b, and then later allow b to move all the way towards infinity. Later on, allow b to move towards infinity. So this whole thing here, this whole thing here from 0 to infinity is really us integrating from 0 to b, from 0 to an arbitrary point b, and then allow b to move all the way to infinity. Allow b to move all the way to infinity. So this whole thing here from 0 to infinity is equal to this thing here. So now it just boils down to us trying to integrate this. So to integrate this, visualize as this. You could use substitution, but learn to recognize it straight away. So visualize this thing here as 1 plus x squared times 1 over 1 plus inverse tan of x. So if you look at this here, this thing here gets multiplied to the top, and notice that this thing here, well, you should recognize that this is the exact derivative of this. So remember, if you differentiate inverse tan of x, if you differentiate it, you will get this, and you should know this by heart. But the point is that this thing here gets multiplied to the top. So then this thing here is the exact derivative of this thing here. So you've got a case of u prime over u. You've got a case where this thing is the exact derivative of this thing. So whenever you recognize this, then you should be thinking about natural log of u. You remember, if you were to differentiate natural log of u, you will have 1 over u and then times the derivative of u. So this thing here gets multiplied to the top. The point is that try to keep an eye out on something being the exact derivative of another thing. Or this thing here is the exact derivative of this thing here. So you are really looking for something in such a way that when you differentiate it, it will then give you this thing here. Well, if you make this to be your initial guess, natural log of 1 plus inverse tan of x. Now, if I were to give you natural log of this thing here and ask you to differentiate it, you would do this: 1 over 1 plus inverse tan of x, and then you would then times the derivative of the bubble itself, which would be 1 over 1 plus x squared, which is exactly this thing here. The point here is that to integrate this, it would be this. It would be natural log absolute value of 1 plus tan, inverse tan of x plus c, but we don't really care about the c because we're going to do definite integrals, so we don't really need the c. The point here is that you could use substitution, but learn to recognize that this thing here is exact derivative of this thing here. So integrate it straight away. So that will then take you to here. So now evaluate this. Hang on. Now evaluate this. So put b into here. So that will then give you this thing here. Put 0 into here. That will then give you this thing here. Remember, tan of x looks like that. Inverse tan looks something like this. Let me start again. Inverse tan of x looks something like this. So 0 would be right at the origin. So this thing here would be 0. So that would be natural log of 1. Natural log of 1 plus 0. So natural log of 1. So 1 is here. Natural log of 1 will be 0. So this whole thing here will be 0. So that will then give us this thing here. So this whole thing here will be 0. And then if you look at this here, b is always positive, and then 1 plus b is always, inverse tan looks something like this. B is always positive. So So this thing is always positive, and then you add another positive number. The point is this whole thing here will always be positive, so we don't really need the absolutes here. So this thing here will then become this. So as b heads towards infinity, remember inverse tan looks like this. As b heads towards infinity, you're heading, the limit will be pi over 2. This limit is pi over 2. So this thing here will be pi over 2. So the whole area is natural log of 1 plus pi over 2. So this area here, this whole area as x tends to infinity is this whole area here is given by this thing here. Okay.